Get the most out of your maps in unconventional play areas using Petrasys Pro. Learn about Petrasys solutions for challenges in unconventional development scenarios. When mapping in unconventional play areas, the first challenge is understanding the regional fairways, followed by examining the local sweet spots to identify prospective opportunities. This often requires integrating data from a variety of sources, all with the intention of producing maps, data, and reports to effectively communicate development plans and recommendations. Today's example is from the Western Canadian Basin and will incorporate structural and rock property gridding, as well as hydrocarbon in place and EUR results. Beginning with regional fairway mapping using the regional source rock thickness, overlain with the regional landing zone thickness, along with any regional pressure windows to identify the high-graded generation and storage trends. Then, at the field level, based on the findings in the regional data, seismic, well, and other rock property information can then be used to begin to identify some prospective targets. In this case, the rock properties include the structure maps from seismic, TOC maps, and thermal maturity maps. And from that data, the spatial extent of the oil and gas window can be determined. Additionally, the dataset includes seismic extracted attribute volumes. Overlaying the maturity map with the seismic attributes highlights some initially prospective areas. When compared to the TOC grid, the prospective areas can then be divided and categorized into primary and secondary areas. Then, when compared to the structural information, in this case an interpreted fault or large through-going fracture, the areas can be divided and high-graded further. Before putting together an initial development plan, however, the prospect quality and the company acreage will of course be compared. In this case, the secondary and tertiary prospect areas are the only areas that overlap with the company acreage. Even without perfect acreage, this is one method for using limited data to begin identifying and ranking a portfolio of prospects and opportunities. Next, a detailed investigation of the well data and drilling results in the area allows for a more in-depth analysis and more informed development plans. The primary development area is in the western portion of the field area. This is on the flank of the main structure. This indicates that there is a key structural trend that was not considered in the previous analysis. The drilling success to the west is a result of a basin-centered gas accumulation. The previously drilled wells will also provide more information on the rock properties, the detailed zone thickness, porosity, and saturation ranges. For initial volumetrics to determine original hydrocarbon in place, the next step is to use Petrasys surface modeling workflows to generate the necessary structure and rock property grids. Then, generate the original gas in place and oil in place maps using the powerful and flexible grid arithmetic functionality, followed by calculating gross rock volume and estimated ultimate recovery using volumetrics calculations. All calculations can be run as a human-in-the-loop automated workflow. This allows for full control of inputs and parameters while providing repeatable analysis on a range of data or intervals and easily updatable results when new data is acquired. With the appropriate set of grids generated, grid arithmetic can be used to create a set of petrophysical maps with the goal of creating hydrocarbon in place maps. Grid arithmetic in Petrasys makes this a simple multiplication problem of porosity, thickness, and saturation grids, resulting in a hydrocarbon column map. Using the same set of grids, the bulk volumetrics can be calculated for different recovery scenarios, as well as on a per area basis, such as the well drainage area, field area, or lease area. The numerical results can then be exported for analysis, while the plots can be posted directly to the map, which allows for export to georeferenced and layered PDF format, which streamlines the sharing of your results. This brief overview examined a small range of solutions and techniques in Petrasys Pro for handling some of the challenges in mapping in unconventional development scenarios and creating a robust portfolio of prospective opportunities. The initial challenge is understanding the regional fairways. Once that's complete, examining the local field areas to understand the sweet spots and identify drilling opportunities is the next step. This often requires integrating data from a variety of sources, all with the intention of producing maps, data, and reports to effectively communicate recommendations within teams and across the organization. In addition to the mapping workflows presented here, there are further detailed workflows for generating per well gross rock volume and estimated ultimate recovery using structural grids, microseismic, and stimulated rock volume. Additionally, the fault statistics reporting allows you to understand the structural and stress regimes of the field area. If you'd like to get the most out of your maps and learn more about our unconventional mapping workflows, please contact us via our website or directly via our information email that's shown on the screen.